right, good morning everybody. This is Mr. Markwood here again on this wonderful Monday morning. Wanted to walk you through lesson 1.1.3, graphing parabolas. So before we get started again, a couple announcements again, as we can see here. Just had our first homework completion. Did you do it? So basically, if you did not get a chance to go through and turn in your homework from last week, make sure you go back and do that. So go back and turn in your homework from last week if you didn't get a chance to. That link should still be open on It's Learning. If it's not, make sure you contact your grading teacher if you have any questions or concerns on that. Also, the Get to Know You survey should be taken for homework points. So that is a graded assignment. It is also on It's Learning. Make sure you go into It's Learning and take that Get to Know You survey so that we can hopefully get a little better just of who you guys are as students. So if we come back into the building, then we can hit the ground running and have a little chance to get to know you guys a little bit better before then. So that's what's going on. So make sure you turn in your homework from last week, do that Get to Know You survey done, then we should be all good to go. So for today, we are doing lesson 1.1.3. I want to put the answers up for the homework from 1.1.2b, and then we are going to do a couple problems together here. All right. Make sure you have your white notebook packet out. Make sure you have your yellow homework packet out, a pencil, and then our yellow cardstock toolkit, which we're going to need at the end of the video to fill out a little information. All right, here's the answers for the homework. If you have any questions on that, please feel free to stop in the office hours today or email your grading teacher if you have any questions. Here are the answers if you want to look at them a little bit longer. Again, it's a video, so just go ahead and pause that. So answers, pause it if you want to see it longer, and we're going to keep moving. All right, so today we are going to be graphing and investigating graphs of quadratic functions. So quadratic functions would be a graph that has the shape of a parabola. We're going to try to figure out all we can about that shape today. So as we read through 123 here, we have been hired to work at a national corporation called Functions of America. Recently, our company has had some growing pains, and your new boss has turned to our team today. It's just going to be you for help. So see the memo below. So please investigate a new function called the quadratic function. Quadratic function is something that looks like this. Y equals ax squared plus bx plus c. And again, when we graph a quadratic function, they're going to have the shape of a parabola. So we are going to make a full report on parabolas so we can let this function know, the CEO of Functions of America, all the details that she needs to know about our parabolas. So let's get started. On 123, we should have 8 parabolas, or 8 quadratic functions that we are going to try to graph. For today, in this video, we are going to focus on y equals negative x squared plus 4. So we're going to graph that one together. We're going to come back in a little bit, and I'll give you 4 more to do on your own for a little bit of practice outside of that. So let's go to some graph paper here. Oh, back page. So let's go and write our function. So our function again is y equals minus x squared plus 4. So we need to graph this function. So I think the best way we can do this is to make a little t-chart or x and y values. And I'm going to say let's pick -2, -1, 0, 1, and 2 for our x values. And we're going to plug those values in to get our y value back out. So for example, let's do -2 first. So y is going to be equal to -2 squared plus 4. So we have -2 squared. A negative squared is going to be a positive. So that will be y equals 4 plus 4. So this is a negative times a positive. So let's get this -4 plus 4. So our y should be equal to 0 or -2. If we change this to, if we plug in -1 next, not change that, but we're going to plug in -1. So again, if you missed that for -2, just go back and rewatch that part of the video, because again, it's a video and you can go back and rewatch things pretty easily. So we have y is equal to minus -1 squared plus 4. -1 squared should just get us 1. So a negative times a positive is going to get us -1 plus 4. So our y should be equal to 3 for that one. 0 should be pretty easy to figure out here. Y equals minus 0 squared plus 4. So 0 squared is going to be 0. 0 times a negative is still 0. So we have 0 plus 4. So y is going to be equal to 4 for 0. Now we can plug in our positive numbers for x. So let's get rid of this. We're going to plug in y equals 1, or x equals 1. So y is equal to minus 1 squared plus 4. This will be minus or negative times 1 plus 4. So we have a -1 plus 4. So this should get us again, y is equal to 3. So look, notice this, is as we have a -1 and 1, we plugged into our function, we get the same y value back out. So if we plug in 2 instead of -2, if this follows the same pattern, I think we should get 0 down here. But let's plug it in and double check just to make sure. Just to make sure. So y is equal to minus 2 squared plus 4. Minus 2 squared is 4. So negative times a positive 4. So y is equal to -4 plus 4. So our y again is going to be 0. So let's plot these points. Let's plot our points here and see what our graph looks like. So we have -2, 0. We have -1, 3. We have 0, 4. We have 1, 3. Then we have 2, 0. So if we connect the dots, our graph is going to look something like that. Or that is what we would call a parabola. So now we have a bunch of questions that I want us to take a look at on the very next page in our packets, next to our graph paper. We're going to try to describe this graph the best we can. So I'm going to write the answers on the right side here so we can all follow along. So how would we describe the shape of our parabola? For example, would you describe it as opening up or opening down? So in this situation, because both of these lines are going down, for that one, I would say this is opening down, opening down. Do the sides of our parabola ever go straight up or straight down vertically? Why or why not? I don't think these will ever go straight, because as we go further and further out, they might get steeper, but it's never going to be exactly straight. Kind of like what we talked about last week with our exponential functions a little bit. So, no, they will not be straight. But if we look at that second one, does our parabola have any lines of symmetry? So what that means is, can we take this shape and fold it so that way we can, or fold on top of each other. So if you look at this picture here, I think if we were to fold it along the y-axis there, that this side would fold over that side and should match up perfectly. So for part B here, yes, there is a line of symmetry. there is a line of symmetry. And what is that line? So right now, this line, this vertical line, would be x equals 0. Are there any special points on our parabola? Anything that kind of sticks out? So for me, this point right there kind of sticks out. For the graph, it doesn't get any higher or lower, depending if it's opening up or not. But this point kind of sticks out because it's not the highest point of this graph. Nothing goes beyond it. It's kind of right in the middle of that point. So in the future, we are going to call that our vertex, right there. That's our special point. That's the one special point, is our vertex. Looking at this graph, there's also two other special points I think I can see on here, which would be these 2 points where our graph crosses the x-axis. So we have our x-intercepts. And the nice thing about this graph is this point, our vertex point, is actually serving as another point, or another special point on our graph. It is also where our graph crosses the y-axis. So we want our y-intercept. As well. So again, as we look, our vertex here is our y-intercept. So where that point is, our x value is equal to 0. That's going to be our y-intercept. So y-intercept is 0, 4. Our x-intercepts are where y is equal to 0. So this is an x-intercept of -2, 0, right, where our y value is going to be 0. So this is also an x-intercept down here of 2, 0. And then the highest point here, this is our maximum. If our graph looked like this, the vertex would be the minimum. So the vertex is always going to be either the max or the min for our parabolas. And that's the information that we are looking for when we are graphing parabolas. So vertex, x-intercepts, y-intercepts, maximum, and minimums. So if we go back a page in our notes to our initial list, right here, what we want you guys to do for today in our asynchronous lesson is to graph these 4 functions and describe them kind of like I did. So we want our x-intercepts, our y-intercepts, max or min, depending on which way it's opening. Is it opening up? Is it opening down? Anything that we can think that might help us describe our parabolas. Anything that might help us describe it. All right, so if you are really feeling ambitious and want to make a poster describing your findings for your parabolas, you can certainly do that, but we are not going to do that for today. Last but not least, we're going to add a couple things to our toolkits. So we have quadratic function, which again, the name of this shape, let's get a marker back on here, is a parabola. And it looks something like that. Or it could also open like this. So either or can open up or down. Special points. We have our vertex, x-intercepts, y-intercepts, and then our special line is the axis of symmetry. All right, if you have any questions, please feel free to come to office hours. That's all I got for you guys today. Have a great rest of your day.